folks. This is the last lesson before our evaluating trigonometry test that we're going to have after the long break, and it's word problems. Yay, word problems. Well, I don't want that recorded in the video because it won't be true forever and ever and ever, right? So, okay, yeah, I'm recording again. Good, now that I've told you guys when your test is off camera. Alrighty, anyway, word problems. We only have 3 questions to get through today. We will have to use our calculator for some of them, and I am going to use the TI-30X2S because it's much better than the battery-operated one. That's the one I'll be using. Can we do it with the battery-operated TI-30XA? Yes, but well, this calculator sucks, right? So let's get it out of here. Alrighty. We start with the real simple question here, talking about angle of depression. I think that the hardest part about these kinds of questions for you guys is going to be drawing the picture. That's going to be the hardest part. So as long as you can draw the picture and you can do some basic trigonometry, you shouldn't find this difficult. It says that the base of a buoy is 1,240 feet away from the bottom of a lighthouse, and this lighthouse, is 130 feet tall. Let's get ourselves a cute little picture. We've got the water, and we'll say that this is the shore. What color should our lighthouse be? Red lighthouse? Okay, red lighthouse, I could do that. Got ourselves a red lighthouse. So red lighthouse, I don't know, maybe it's one of those ones that people live in. It does kind of look like a UFO is abducting somebody, doesn't it? Whatever, lighthouse. Anyway, this lighthouse is 1,240 feet away from a buoy that is out in the water. And buoys are those deals that are out in the water that have the floating bells on them. You know that Taco Bell commercial that they got right now, like where the bell, boom. Yeah, okay. So I never claimed that I could draw. Okay. What do we know? We know the buoy is 1,240 feet away, and we know that the lighthouse is 130 feet tall. Picture definitely not drawn to scale because this is like 10 times as long as that, right? What it says is that the angle of depression from the top of the lighthouse to the base of the buoy, oh, it says to find the angle of depression from the top of the lighthouse to the base of the buoy. So let's use black. So you have a basic triangle going on right here, right? Like so. Now the angle of depression is always read from the horizontal, and we'll just go ahead and say that's a 90-degree angle. The angle of depression is always read from the horizontal. So we've actually been asked to find this angle right here. So we have a triangle, this leg is 1240, this leg is 130, we've been asked to find this angle. We can approach this one of 2 ways. We can either find this angle, because this is in the triangle, and we can just say that this, whatever this is 90 minus our angle, and then we could work from there. Or the even easier thing to do, which would be remember that alternate interior angles are always congruent. So this angle of depression is equal to this angle of elevation. From this angle of elevation, I can see 2 sides, namely the opposite side and the adjacent side. So which trigonometry is going to be useful for us with opposite and adjacent? Tangent. We know that tangent of our theta is 130 over 1,240. It does say that the angle is in degrees. So we're going to grab our calculator in a moment. We're going to make sure that it's in degree mode. My job is to solve for theta, though. How do I get rid of tangent? Tangent inverse, yes. We need to take the tangent inverse of both sides. Tangent inverse here and tangent inverse here, like so. Tangent and tangent inverse will cancel each other, leaving us theta equals. Theta equals the tangent inverse of 130 divided by 1,240. Time for our calculator. like I said, the question does say in degrees, so you need to make sure that your calculator is in degree mode. Mine is in degree mode from first period still, but if you need to change it, DRG will handle it for you. Make sure your calculator says DEG on it. Tangent inverse is right here above tangent, so we need to hit second tangent, and then 130 divided by 1240, be a good mathematician and close your parentheses, hit equals. Pow, there you go. It says round to the nearest tenth, which means the 8 rounds the 9 to a 10, which actually rounds to 6 degrees. There you go. About 6 degrees, yeah. Well, think about it. It should be a very shallow angle. Look how far apart they are. I mean, picture not drawn to scale. If you were looking at something really, really far away, do you have to look up real high? No. So the angle of elevation from your eyes down here should actually be pretty darn shallow because of how far away it is. Remember, this thing is 10 times further away than it is tall. It's got a really shallow slope, like a slope of 1 over 10. Okay. So yeah, we would expect it to be a very small angle. Not too bad, right? Not too scary? Okay. Of course, on this calculator, you have to type it backwards. So you have to do the fraction first and then do second tangent. Next question. From the top of a 100-foot wall, a man observes a car moving towards this wall. Say that again. You're standing on the top of a wall. You're looking at a car. It's driving towards you, okay? So from a 100-foot wall, a man observes a car driving towards him. The angle of depression of the car changes from 22 degrees to 46 degrees while this car is driving toward him. I want to know the distance that the car traveled on the ground. A picture would help. A picture would help. And actually, let me draw it as 2 pictures. Here's our wall. We said it's 100 feet tall. And on the ground somewhere out here, there's a car. I was drawing a car in first period, but it was really sad drawing. You know what? I drew one for the lighthouse. Let's do it. We're going to draw ourselves a green car. What? Yeah. There you go. There's your car. Okay. Anyway, here's our car. It says that this car is driving towards the wall, and what we know is that the angle of depression changed from 22 degrees to 46 degrees. So right now, I have an angle of depression of 22 degrees. I'm going to draw the picture again, only this time angle of depression will be 46 degrees. I'll spare you the picture this time. It's the same car. And of course, right angles. Awesome. What we want to know is how far this car drove when this angle changed from that to that. What would I need in order to figure that out? Come on, guys, what do you need? I need the adjacent side. If I knew these 2 lengths, couldn't I just subtract? Because this one's going to be shorter than this one because it got closer to me. So I just need the 2 adjacent sides so I can subtract. All right. How about we call those x1 and x2? Since they're horizontals, we'll call them x's. x1, x2, and we know that x2 will be smaller than x1, so we're just going to find those 2 lengths and subtract, and we will know how far that car drove. Just like in the last question, an angle of depression is always going to be congruent to the angle of elevation that is alternate interior from it. So that means there's a 22-degree angle here, and there's a 46-degree angle here. And just like the last question, from my angle, I know the opposite and the adjacent sides. However, if I were to use tangent, the variable that I'm trying to solve for, x1 and x2, is in the denominator of my fraction. There's nothing wrong with that. It's just going to take a little bit more algebra than I feel like doing right now. So instead of using this angle, instead, let's use the other angle up here, which is going to be 90 minus 22. And this angle will be 68 degrees. Same thing over here, 90 minus 46, 44 degrees. Again, could I have done it the other way? Yes, it just would have taken a little bit more work. And I don't feel like doing more work right now. From the orange angles that I just drew in, the 68 and the 44, now I'll use tangent, opposite over adjacent, so my unknown values will be on top of the fraction. Tangent of 68 degrees is opposite over adjacent. I get x1 by itself just by multiplying both sides by 100. And we'll pull the same trick over here. Tangent to 44 degrees is opposite over adjacent. Multiply both sides by 100. And we now have x2. We said the distance the car traveled is the difference between these two lengths. This one's the bigger one. So we just subtract. Distance is going to be x1 minus x2, which is 100 tangent 68 degrees minus 100 tangent 44 degrees. Now, I don't want to round ahead of time. Could I figure out what 100 tangent of 68 is and round it? Yes. And 100 tangent of 44 and round it? Yes. And then subtract? Yes. But if you do that, you're working with two different rounded numbers, which means you had two inexact numbers, and then you found the difference between numbers that were technically wrong. That's like stacking errors on top of errors. I would avoid doing that and instead go directly to using the calculator and don't round until the very, very end. That's how I would handle that, which will be much easier to do with this calculator. On. In degree mode, 100 tangent of 68. You need to close the parentheses on the tangent to tell the calculator that the argument of that trigonometry is done. Minus 100 tangent of 44 degrees. Be a good mathematician, close those last parentheses, hey, it equals. And you will see that that car drove almost 151 feet. Now, it didn't tell me what to round to, so I'll just go to 1 decimal. The test will be very specific about what you're going to round to. So 150.9 feet. You seem to not like that answer. Yes. Just looking? Okay. So our distance is about 150.9 feet. So you don't have access to that calculator. How do you do it with this calculator? Well, you can still. You just have to be very, very careful. Make sure it's in degree mode. This one is in degree mode. Remember, you have to type your arguments first. So 68 tangent minus 44 tangent times 100 is. What happened? Oh my gosh. I'll tell you what happened. This calculator doesn't understand the order of operations. So it didn't know to multiply by 100 before the subtraction. So what do you do? Like I said, it is possible. The easiest way to pull this off on this calculator is to realize that 100 is a GCF, and it can be factored out, which means you could multiply after you do the subtraction. Then the calculator will be just fine. So I could say tangent 68 minus tangent 44 times 100. 68 tangent minus 44 tangent equals times 100. Or you can become a master of the parentheses commands that are on here, but I'm not on this calculator, to be honest with you. I would just factor the 100 out as a GCF. Do the subtraction between the trig, then the multiplication. What do you think so far? Not too scary hard? Not too bad? Cool. So let's ramp it up. Oh yeah, it's already got a drawing for you. There's a reason. A large helium-filled penguin is moored at the beginning of a parade route, awaiting the start of the parade. Two cables attached to the underside of the penguin make angles of 48 degrees and 40 degrees with the ground and are in the same plane as a perpendicular line from the penguin to the ground. Needed a breath after all of that. So rather than asking you to draw that thing yourself that I just described, I gave you the picture. Okay. On the test, there is a question like this. I gave you the picture. I'm not going to penalize you for not having good artist skills. So I don't want to let the picture get in your way. There it is. I drew it for you. Okay. What we do know is that the places where the cables are connected to the ground are 10 feet away from each other. What we need to know is how high above the ground is the penguin right now? We were told the angles where the cables attached to the ground are 48 degrees and 40 degrees. There's 40 degrees, there's 48 degrees. I hope it's obvious that as you get closer, the angle is larger. Imagine you were walking towards a tall structure. The closer you got, wouldn't you have to turn your head back even further to see the very top? Does that make sense? Okay. So that's why the angle that's closer is the larger of the two angles. You know what would make this question a lot easier? If the triangles weren't overlapping. I could have drawn the last picture as overlapping triangles. I chose not to, though. So I'm going to draw this as two separate triangles. I'll spare you the drawing. We know that there's an H here, and there is a 40-degree angle here. Then this triangle with the 48. Picture's not drawn to scale. We know this is H. We know this is 48 degrees. Now what? What's your idea? Which one would you like to call X? So you want to call this X? If we call this leg X, which by the way is right here, then what is this leg? X plus 10. This is how you're going to tackle this question. Because from this 40-degree angle and this 48-degree angle, once again, we can use tangent, opposite over adjacent. So that's what we'll do. Tangent to 40 degrees is H over X plus 10. Because this length is X, and this is 10 more, so X plus 10. Hold on. And then we have tangent of 48 degrees is H over X. Ideas. What do we got? Now that I have these two systems there, what can I do? How can I set them equal to each other? So if I multiply both of them by their denominator, they will both say h equals. This one says h equals x plus 10 times the tangent of 40 degrees. And this one says h equals x times the tangent of 48 degrees. And yes, since they both equal h, these two things equal each other. I could set them equal to each other now. Obviously, we're going to be solving for x because that's the only variable I have left. Well, in Algebra 1, we learned if we're trying to solve for a variable, we have to get all of the terms with that variable to one side, right? That means here you are going to have to distribute. But I am not going to round, so I'm not going to figure out what tangent of 40 equals because I don't want to round early because I'm going to have to round at the end. So you try not to round until the very, very end. Is that a question or a stretch? Question. Okay, what's up? No, because what that would give you is tangent of 40 over tangent of 48 equals x over x plus 10. How are you going to get x by itself? No, that won't work because it says x over x plus 10. How are you going to isolate x if you do that? The answer is you can't. No, this is the only way to do it. We now have x tangent 40 degrees plus 10 tangent 40 degrees equals x tangent 48 degrees. The way I see it, I have two terms with x's in them. Might as well move them all to one side. Subtract this to this side. Getting closer. Still trying to isolate x though. How? Take the x out of each one. Also known as factoring. You factor out that x as a GCF, just like I told you to do a moment ago with the 100s. And x will be alone now after you divide both sides by the expression in the parentheses. That's going to give me x equals 10 tangent 40 degrees over tangent 48 degrees minus tangent 40 degrees. Whee! Mr. M, can't I just cancel out the tangent 40 degrees? No, you can't, bad algebra. No, because this minus sign is stopping you from doing that. Not allowed to do that. Now, if that wasn't there, could I cancel out the tangents of 40 degrees? Of course I could, but it's there, so I can't stop that from, I can't let that happen. You will need a calculator now. And I'm not even going to attempt to use the ugly calculator on that. If you have to, strong suggestion is when you type this into the calculator, write it out to 4 decimals. If you write out all of those to 4 decimals, then you will get close enough to the right answer to know which one to choose. But since I have a good calculator, numerator is 10 tangent 40 degrees, close your parentheses, divided by Now this calculator needs to be told that there's more than one object in the denominator. The only way that this calculator knows where the denominator begins and ends is if you group it with parentheses. So I open a set of parentheses for my entire denominator. I say tangent of 48, I close that tangent, minus tangent of 40, I close that tangent, I close my denominator, and I hit equals. There's your answer, 30.9 feet. Yeah. On which one? Oh yeah, it's possible. I just don't want to. You have to use parentheses. You can't, I mean, that calculator does have parentheses structures. They're just more difficult to use in my mind. Yeah, here, I'll try. I mean, why not? I don't mind being wrong. I'll just go ahead and give it a try. So 40 tangent times 10 equals, divide by, parentheses, 48 tangent minus 40 tangent, close parentheses, equals. Hey, I did it. But it was a lot more difficult. But it worked. It worked. Gymnastics? Sure, mental gymnastics. But that's it for the word problems. If you can handle this last one, you can do any word problem. Don't let drawing the picture be what stops you from getting a question correct.